Quick example of the greatest common divisor and the least common multiple here. The greatest common divisor of a pair of numbers is the smallest factor that's common to both of them. So, for example, using this notation, the GCD of 15 and 6, the greatest common, sometimes called the highest common factor in some parts of the world, but the greatest common divisor of 15 and 6 is 3. 3 is certainly a divisor of 6, and 3 is certainly a divisor of 15, and it's the greatest such number with this property. Now, the least common multiple of 15 and 6 is 30. Now, you can use the prime factorizations, but it's usually pretty easy to do these small numbers just by inspection. So the least common multiple is the smallest integer that takes both 15 and 6 as factors, okay, or as divisors. Okay, so this would be 30. Now, an interesting thing to notice right now is that 3 times 30 is equal to 6 times 15. I'll write that down. 3 times 30, and that's a property that we're going to use. 3 times 30, the product of the GCD and the LCM, is equal to the product of the original two inputs. 3 times 30 is equal to 6 times 15, okay? And that's kind of why the proof of it uses the prime factorization, but we won't go through that. Anyway, we'll use this important fact right here to help solve this problem. Now, you can read the problem. This is similar to an SMO Junior problem. The difference between the LCM and the GCD of a pair of numbers, one unknown and one known, is 2256. Determine the value of n. So all of this is just directly from the problem statement. The LCM is equal to the GCD plus 256. You could have written that as LCM minus GCD. And the LCM is always larger, right? The LCM is always larger. So LCM minus GCD translates to this, okay? Now, the LCM must, by definition, must be a multiple of both of the numbers, namely 78 in this case. And what we do is we list these divisors here. We list the divisors of 78. It's pretty important. And then we divide 2256 by 78. Notice we get this remainder of 72, which implies the GCD has to equal to 6. And that's easy to see if you just look at this statement right here. This would be 6 plus 2256. And you see this division statement makes life pretty easy for us because bumping it up by 6 means this would be equal to 29. You don't have to explicitly know 29, but you just have to know that this would be a multiple. Okay, so we have 29 times 29 times 78 right here. Okay. All right, so that handles the fact that the LCM has to be a multiple of 78, and it's also going to be the smallest one since you just bumped up 6 from this expression right here. Okay. Now let's take a look at what does all that mean. Now we're going to use that fact that I told you about, that the product of the two input values, 78 is a given, 9 is the unknown, is equal to the product of the LCM and the GCD. But notice right here we've already determined what those are. That's 2262 times 6. Okay, now if you do the arithmetic on this, let's see, you would get what, 13n. 13n is equal to 2262. Okay, and then when you divide 2262 by 13, you get 174. N equals 174. Now we could just circle the answer and say we're done, but let's go ahead and verify. These numbers are fairly small, but this is the answer. We were seeking the n that met the conditions. So let's see what's up with that. All right. So 78, we've already seen that 78 is equal to 2 times 3 times 13. That's the prime factorization. 6 times 13 is 78, right? Okay. Now it turns out 174 174 is equal to 2 times 3 times 29. That's a little harder to see, but 6 times 29 is 120 plus 54, which is 174. Okay, so there we go. And so you can see the GCD right here. That would be, this part would be the GCD. The circled part would be the GCD, which is 6, which we were able to conclude just through logic up here, right? All right, and then the LCM would just be the product of all those. In other words, the LCM, and you guys verify if you want, but the LCM is just the product of all the prime factors without repetition. So the LCM is equal to 2 times 3 times 13 times 29, okay? It's not hard to verify that's equal to 2262. But anyway, y'all, that's it. Thought it was kind of a cool little problem. The solution is n equals to 174. Thanks for viewing.